we're going to show you the key skills you need when evaluating an investigation.
And the investigation we're going to carry out is the reaction of hydrogen peroxide using a catalyst to produce oxygen and water.
Now, this is sometimes called the elephant's toothpaste reaction, and you'll see why in just a second. So, in these flasks, we have our hydrogen peroxide, along with some food colouring at the top, just to make it colourful, and a splash of washing up liquid. Now it's time for us to add our catalyst.
And the catalyst we're going to be using today is potassium iodide. Ready, Simon?
Ready, Shinny?
3, 2, 1. That's all steam, isn't it? Still going. That food colouring is really making it look like toothpaste.
Well, now you know why it's called the elephant's toothpaste reaction.
Exactly.
So the oxygen gas that's being produced by the reaction is being captured in bubble form by the washing up liquid that we put in. So you can see with your own eyes just how much oxygen is being produced.
Yeah, it's absolutely spectacular. And I can't believe that this process is happening in our bodies every single day.
Minus the food colouring and washing up liquid.
Yes, I mean, our livers contain an enzyme called catalase that has a similar effect to breaking down harmful hydrogen peroxide, which can be found in foods like potatoes. We've cleared up all of that mess and we're left with 2 test tubes full of hydrogen peroxide. Now, I'm going to add some of this sludge to one of the test tubes. This has been made in a food processor and it's fresh beef liver mixed with water. Now, in the test tube, I've also added a squirt of washing up liquid, and that's to help us see the reaction as the gas gets generated. So a lump of it goes in there.
Oh, wow.
Now, this sludge contains the natural enzyme catalase, which is very similar in effect to the catalyst that we used, potassium iodide, in the previous demonstration.
So you can see it happening, but how are you going to measure the rate of reaction?
Okay, good question. So I'm going to add the sludge to this test tube of hydrogen peroxide, and I'm going to stick the bung on top, and the gas that's generated is going to push down and hopefully push the syringe, and you'll be able to measure the quantity of gas using this cubic centimetre scale. So, ready to do that?
Yeah, we could measure it for, say, a minute. Put the bung on, and I'll start the stopwatch.
Okay. Right, bung goes on.
Stopwatch started. There it goes.
Yep, so you can see the syringe just push back with the gas. Yep. It's quite fast, isn't it?
Well, we've only been going for 10 seconds and it's made over 20 cubic centimetres. Go.
59 cubic centimetres.
Just shy of 60. I wonder if the rate of reaction will change if we change the temperature.
I think you're right. I think at higher temperatures, the reaction is going to be a lot more vigorous. That's my prediction.
Let's find out.
So we've done these experiments twice using 7 different temperatures, and we've recorded the gas produced at each temperature. And I've plotted the results on a graph, and you're going to draw the line of best fit.
Okie dokie. So something a bit like this. What about this point? This one doesn't seem to match the trend of all the others.
Yeah, this is an outlier or an anomaly, and that suggests that there was some kind of mistake made when taking that reading.
Second reading.
Yeah.
That's my fault. Sorry, I think I messed up the temperature dial on the heat bath. Can we forget about that?
Yeah, we can discard it for now, but in an ideal world, we'd want to redo that reading.
But your hypothesis was correct. Up until a point, as we increased the temperature, the volume of gas did increase.
Yeah, but then it started decreasing. Why is that?
Well, the enzyme that we were considering comes from our bodies, which are at about 40 degrees Celsius. So it would make sense if it was the most efficient at breaking down hydrogen peroxide at that temperature. So the enzyme would start to denature and become less effective as an enzyme.
So in terms of this investigation, what improvements would you suggest?
Well, I could definitely be a bit more careful with the heat bath.
Yeah, but I also think we should take a lot more readings.
Oh, and decrease the temperature increment.
Yeah, just to make it more accurate.
Absolutely.
The main points you should remember when evaluating your investigation are: decide on whether your data is of good quality. Check for any outliers and anomalies and decide how you're going to treat them. Compare your conclusions with your predictions. And then finally, suggest ways that you may be able to improve your investigation.
I can't believe you used that liver. You know I'm vegetarian.
Well, I was actually going to fry it up for dinner tonight.